Paul Hopewell. Welcome back to my shed. This is where I make all sorts of stuff, usually for old classic motor vehicles or machines, and I show you what I went through to get the project done. In this video I show you how I went about finishing a steady rest for my South Bend 13 lathe. This is part 2. In part 1 I'd just completed the internal left-hand threaded studs. I showed you how I made some components, but I didn't do a very good job of telling you how the 3 adjustable legs should work. So rather than blather on, I'll give you a brief preview of how they should work, by way of an apology for my brain fog moment. As you can now see, the left and right hand threaded combination is designed to work together as a multiplier. Ignore the Jubilee clip, it only holds it in the vise without damaging it. I've had a change of mind about the type of hinge I'm going to use. I've decided to hide my hinge. When I say hide, I mean construct the hinge assembly so that it's recessed inside the main body of the supporting ring. That means I need to cut a slot into the outside diameter face that's parallel to the front and back faces, providing a true guide for the hinge. The hinge is basically going to be a bit of black bar that'll be profiled and welded in later, but for now I'm preparing to dig out the slot. As you can see here, I initially started to rough the slot out with the end mill, but because there was a lot of material to remove, I simply made a few flat spots across the top and then changed the end mill for a drill. This was much easier and far less wearing for the end mill. The end mill was reinserted into the collet to break through all the webs. Mind you, this process still required me to blow swarf out after every other pass to prevent binding the captivated swarf between the cutter and the material being cut. Now that the slot's roughed out, I replaced the 12mm cutter for a 13mm. This bit of black bar is 9/16 of an inch thick, and before I insinuated it into the slot, I warmed it up on a belt sander on both sides just to remove the slag or the scale. I've just carved up a couple of blocks, and after a little bit of hand grinding I clamped them together while packing a 1mm thick strip of nails between them. Then I clamped these to the ring on the opposite side to the hinge using another G-clamp. I understand the other side of the pond they are known as C-clamps. I make no excuses for my welding, and at risk of repeating myself too much, I'm not a welder. In my books, welding is an art, and I'm not an artist. But what I do suits my purpose. If it's important, then I get the welding done by an expert. That's the clamping lugs done. I'm using this bit of 1-inch plate as the base that's conveniently cut to size. In it, I've got to cut a 90° V-groove and a 4mm wide relief slot, as the top of these V-slides are about 3.5mm wide. Now that I've marked the profile, I can get on with the process of removing the material. Initially, I thought of using my tilting vise for this operation, but the jaws wouldn't open enough, so it was plan B. I know I can tip the head, but it's nicely set at the moment and it can be such a pain to put it back. Providing I don't push too hard during the roughing out process, holding it this way will still work. This V-groove is for restraining purposes, so as long as I get it as accurate as possible, I won't need to scrape it in after machining. Oh, and for the observant of you, I did nip up the 3 loose DTI screws. I absolutely love this high-speed steel shell-end milling cutter because I can take quite big cuts on this little milling machine and it doesn't give me any grief. This V-groove was cut out and finished in 2 passes, but before I went all the way across on the roughing cut, I buried the tool in to get a measurement, then I made an adjustment to leave me with 1mm on the bottom and the side faces. The last remaining 1mm was an easy adjustment to finish it off. I put the workpiece back on parallels, and with the 4mm diameter cutter I plunged down 3mm into the groove and cut a relief slot. Now at this point, if by tapping it I hear or feel any free play, I would have to find out where it was and scrape it out, but as it happens, it was good. Holding the ring in the jaws and placing the base plate on the slide, I fabricated 2 7mm thick supports to snugly fit between the two. After persuading a few pigeons to contribute to my welding prowess, I broke out the angle grinder to polish out the high bits. In order to get on with the hinge, I used the bandsaw to split the two halves apart. After profiling the hinge block, I welded that in place and filled the missing weld at the joint faces. Marking out the hinge position, I drilled it using a 6mm drill and fitted a temporary 6mm shoulder bolt. After all, I didn't want to fit a 10mm pin straight away, just in case. Here's where I admit that the fag packet sketch didn't work out the way I wanted it to. The support ring is 28mm thick, but the threaded sleeves are 23mm diameter, and that means that the ring is going to be quite thin where the sleeve passes through. And the pinch bolts will be struggling to grab the sliders unless I come up with an idea, and quick. So I decided to weld on some reinforcing pads to both sides of the ring. After some more welding and a bit of help from Mrs. Shed Dweller, it looks alright, doesn't it? I planned to clamp through the ring into a clamping plate, and to make the plate I had to find out how long it had to be. For this task I used a bit of old tech. Under the slides are a couple of tailstock clamping slides. By using the caliper gauge, I determined that the maximum width was 116mm, so I made the clamping plate 115, with two small radiuses on the opposite corners. Cutting the plate to length, drilling the hole and rounding off the radiuses, I welded a 10mm lock nut to the underside, and obviously it wasn't a nylock. I spent a good few minutes here before committing the final position for drilling through. If the hole was off by a millimetre or two, the clamping plate had enough meat on it to lose some weight if necessary, but thankfully it didn't come to that. The drilling operation was completed on the pedestal drill, and you may notice that whenever I make a cut using this drill, the whole lot looks like the whole thing is made of rubber. Don't worry, the drill is mounted on casters so I can move it about, and the camera tripod is quite bulky and heavy. But whenever I pull down on the hand wheel, the casters move around a little, giving the impression that the camera's attached to my chin. You'll also notice that I'd used the end mill on the drill. The end mill is the same size as the drill and was only used to make a spot face under the cap head screw. The locking nut was welded on to provide friction to the cap head bolt. The reason is that the friction will rotate the clamping plate into position before tightening, and conversely slack off before rotating out of the way. The opposite side to the hinge will need some sort of fixing, but I've got something that's been kicking around for ages, but for the moment I'll use a 10mm bolt. The 6mm shoulder bolt in the hinge isn't a particularly good fit, so to stop the two joint faces sliding across each other, I secured it with an engineer's clamp. I firstly piloted a hole with a 6mm drill through. Then I completed the 10mm clearance hole to just below the top lug. Removing the top half, I completed the drilling operation for the 10mm thread and fitted a temporary bolt. To finish off the hinge, I used the 6mm dowel for setting purposes and then drilled through using my best 10mm drill. I didn't use a reamer here as a close fit would suffice, and as you can see the dowel I'm using is pretty good fit. Before putting the hinge pin in the lathe, I used a hacksaw to mark the two places on the pin for making two circlip grooves, but the marks had to include some thin washers. Cutting these two grooves, I had to be careful not to cut too deeply because I wanted the circlips to be a firm fit. Right, now I've got to machine 3 radial holes at 120 degrees apart in the body of this support ring. These radial holes, when finished, must meet in the centre of this ring. I used my universal indexing chuck for this purpose, and because the base of the ring sticks out too far to be able to rotate it, The whole assembly was mounted on parallels, then set true. Here you can see that the ring base just misses the milling table when it's rotated. And to set the ring true, I referenced the sticky pin against a telltale mark around the circumference. While drilling the pilot holes, the pressure was too much for the universal chuck's pivot, so the first hole ended up somewhat misaligned. After a reset, this first hole had to be opened up very carefully to make sure that it was still in line. The holes were opened up to 16mm using a 4-flute end mill, so any pilot hole mishap was merely an inconvenience. The sleeves were all machined to 23mm, so I wanted these bores to be between 22.99 to 23.01. It was hard work with this boring tool, even though the cutting tool was sharp, as sharp as it could be. After machining, all 3 holes ended up at the top end, with one topping out at 23.015. But because I'm the product inspector, I passed it off as a mild non-conformance. After a little TLC and a lick of paint in the hands of Mrs. Shedweller, the sleeves were ready to be pressed into place. To prevent any damage to these thin-walled sleeves, I screwed the caps on and used them as protectors over the threads. The amount of pumping leverage I have to use to get parts pressed together gives me a good idea how much pressure it took, and in this case I reckon about half a ton. At this stage, I needed to mill the guide slots into the sliders, and after checking that they fit the sleeves, I set up the milling vise, and I also put a stop to maintain the component position. Then I used my favourite wet tissue trick to assist in centering the cutter over the workpiece. With the 6mm cutter set centrally over the slider, I could mark out and set the cutter to start and finish 6mm away from each end. For setting purposes, I used marking glue and an appropriate scribing tool set to 6mm. I could have just cut a slot all the way along each slider, but I decided to restrict the travel purely to prevent the slider falling out should I forget myself. I almost always use a marker somewhere with a setting number beside it, prompting me to stop or start at the right place. After completing the slider slots, I put them to one side to get on with the next operation. Fitting the internal left-hand threaded rods is where my brain farting reached a new peak. I needed the threaded rods to turn with the cap but remain loose, as I've mentioned before. The solution was to pin it, a quite simple solution, but that wasn't the problem. Where I went wrong is that I used a bit of 3mm wire and pinned it over at each end. Then I had to polish out the missed hammer marks. I should have used a slotted spring pin. That would have looked much better. To secure the internal slider and to lock it into place is going to need 2 more items. They are locking bolts and key pins. The key pins are nothing more than a short piece of threaded rod that's been shaped at one end to fit inside the slider slot, and the other end has been slotted in order to adjust it with a screwdriver. To slot the short piece of threaded rod, I could have set up the milling machine and used a slitting saw. I could have, but I used a hacksaw with 2 blades in it. It was much quicker. The locking bolts I had were a little bit too long, so I had to shorten them. After shortening them, I drilled a 6mm hole in the end in order to take a brass insert. After all, I didn't want to damage the sliders by gnarling them up with an unprotected bolt. All three of these brass caps took about 3 minutes to complete, and when fitted to the locking bolts should protect the slider shafts when they're locked down. The sliders will also require some method of adaptation and protection. As I had a good length of copper bar, I decided to use this to make the extensions and workpiece protectors. I made 3 of these in the first instance, but there's nothing stopping me from making any type of adapter, short, long, flat, curved, but that's for another day. These copper inserts are a slip fit, and to stop them from falling out should only require a smear of grease. The locking bolts and the key pins are on the same centre line from opposite sides. So after marking out the starting position for each hole, I drilled through with a 6mm tapping drill and then drilled halfway through with a 10mm tapping drill. After which the hand tapping process could be done first with a 6mm thread and then for the 10mm thread. This is the real reason that these blocks were welded onto the side of this main ring. The thicker block was to hold the 10mm locking bolts and the thinner block to hold the key pins. I know, and I'm sure you can see it, but these blocks aren't exactly in the right position. I'm not bothered about that because it makes the main ring look like a casting, sort of. With the 6mm threads completed, testing each key pin is merely a formality. Freehand tapping until you get a full cut is a bit like trying to freehand draw a straight line between 2 points with a rubber pencil. I would much rather tap holes with a powered device, and that powered device, be it a drill or a mill, requires that the tap to be held in a special chuck, and I would just love to get my hands on one of those. Anyway, at this point I cleaned a bit of paint off the joint faces and started the assembly process, starting with the hinge pin. There was probably a tiny bit of paint in the hinge assembly necessitating the need for a little violence to insert the pin, and I'm thankful that everything else was plain sailing. All 3 cap and threaded rod assemblies were wound into the sleeves, then the sliders were inserted and engaged freely with the left-hand threaded rods. The key pins were fitted and locked into position so as not to bind in the slider. I fitted 2 of the slider bushes and then inserted the clamping bolt before fitting the last slider bush. A quick mention about these bushes. Having these types of bushes allow me to replace them with different types as and when I need them. I didn't make roller type tips for these sliders because, well, I don't need any. Not yet, but that can be addressed as and when necessary. Now I can fit the locking bolts into position. The brass tips will help prevent damage to the sliders when they're used. You can see the threaded rod cum T-bar that I used to clamp the ring together. I might change it at a later date, but if it works okay, I'll probably leave it as is. As always, there becomes a time when all the guesswork has to be tested, and for the first outing I used a good long length of 3/4 inch medium wall black pipe. Admittedly, it would fit down the chuck spindle tube, but let's ignore that for now. Using the lantern style tool holder that I made while making this steady rest, and a high-speed steel tool, a modest chuck speed, feed rate and depth of cut, the finish was good. So despite the pipe's outside walls being a bit gnarly, the end result was a success. The other thing about this pipe is that it was slightly bent. The split steady rest was set up near the chuck and then opened and moved toward the tailstock end and closed for this operation. That's why the pipe lifted a little when the rest was opened. During this video I had a problem with my microphone, so you'll probably notice a change in the quality. I hope it didn't spoil the video for you, but as always, thanks for watching and bye for now.